is Matt Baker from Butler, forgive me, from the Moors for the Future team, who's going to be taking us through the next story around Sphagnum reintroduction in the South Pennines. Matt.
Okay, thanks. I'm Matt Buckler. I'm the Programme Manager for Conservation and Land Management at Moors for the Future. I'm going to talk... I've been at Moors for the Future since about 2004. Just to sort of reiterate some of the conversation that Pam and I were talking about, the South Pennines, when I'm talking about the South Pennines, is the South Pennines Special Area of Conservation, which goes from Matlock to Skipton, and not the South Pennines Natural Character Area. So, because of the talks that we've had, from Penny and Richard, and Angus is coming up after me, the main thing that I'm going to be talking about is the work that we've done to get conditions appropriate for sphagnum to happen. So, this is an area of Bleaklow in 2003, just after a large fire went across it. You can see the sort of extent of the damage that we've got. And you can see that there's been significant amounts of erosion on that, so that these gullies are sort of 2 to 3 metres deep. This is up on top of Kinder. You can see as the erosion is happening, that the peat dries out very, very significantly during the summer. So there is still areas of moisture, but the peat hags themselves are very, very dry, and this isn't good conditions for sphagnum to grow. Another issue up here is to do with the winter. Because of the climatic conditions, it's about, the temperature fluctuates around zero for large parts of the year during day and night, so we get lots of freeze-thaw action. So this separates the peat out and exacerbates the erosion. So you get situations like this. So this needle ice issue, which can cause the peat to separate. Obviously, the weather conditions there, the weather conditions up here aren't all bad. The blanket bog has formed because of the large amounts of precipitation. And this is a picture of the Pennine Way on Home Moss, taken in 2005. And that sort of levels of cloud on here are quite common for this area. You can see the amount of vegetation on it. And the fog is probably a key factor in terms of getting sphagnum back here. Again, the peat is eroding here quite significantly. What happens here is that the gullies are forming, water is flowing off those very, very quickly, and you get extensive areas of erosion. You get extensive gullying, which will go down to the mineral soil. So you get areas like this. Once this is happening, there's very little chance of sphagnum growing back on this. The water is going to be flowing off the drier areas, which are drying out, flowing down these gullies very, very quickly, and the water moves off this system very, very quickly, none of which obviously is ideal for getting sphagnum to grow. So what do we do about that? This area of Kinder, we get areas of extensive areas of bare peat. This is quite a stable situation because of the instability of the peat. Similar to the situation with sand dunes, they stay as they are because of the instability of the substrate. So, as Penny said, lots of the sites that we've been working on happened in 1976 and are still there. So what we've got to do is stabilise the peat in order to get vegetation to grow on it. The first thing we use is heather brash. This is materials cut on. This is Worslow Moor in the southwest peak. And there's a lot of sphagnum in this heather brash, and some of that comes with it. We've taken a lot of material onto the moors of the Peak District in South Pennines. Approximately 40,000 bags like this have been flown up onto the Peak District since 2003. Each one of these bags covers about 64 square metres of bare peat. As I said, this is all flown up. Each helicopter flight carries between 6 and 10 bags, so you can see that there's a significant carbon footprint to what we're doing, and all of this material is then flown onto site and spread by hand. Bags are collected up and removed, ideally in one winter season. We have to do it in the winter because that's when the seed is in the heather brash. quite often not ideal conditions. Just think about the picture of Black Hill with the footpath going across it in the fog, and imagine trying to fly this number of bags of heather brash onto that at that time of year. It's quite often entertaining. So what does the heather brash bring to this situation? Okay, so you've got this picture here. You can see that the heather brash, there's heather seeds germinating in it. There are grasses in it. This will have mosses and lichens in it. The heather brash has mycorrhiza in it, which is critical for getting the moorland plants to grow, and which is lost when you lose the peat during wildfires. But the other thing that it's doing is it forms a lattice over the surface, and this stops the peat eroding far more than you would expect. So there are areas where we've just done heather brash work. The heather brash will stay there for a long period of time and stabilise the peat. On steeper slopes, we use this material, a geotextile material, although the slopes that we wouldn't use heather brash on now have got much steeper. So when we started, slopes over about 30 degrees you wouldn't use heather brash on. Now it's almost sort of 45, 50 degrees you would still use heather brash on it. This material, we fly it up at the same time because we have restrictions in terms of bird breeding season. Once it gets wet and then freezes, it becomes virtually impossible to deal with it. So the logistics of doing this are quite tricky. Doing this stuff with wet and freezing, it's entertaining. So we're using the heather brash and the geotextiles. You form this sort of skin over the surface. This will obviously break down. It's all aerobic. It will break down fairly quickly. And so what we need to do is to tie the lattice together. And the way that we tie the lattice together is to use grass seeds. The grasses that we use are amenity grasses because they're cheap and we can put down a lot per square metre, which means that you get a sward cover quite quickly. Then they're also not very resilient. You need the right chemical conditions for them to grow. As Penny has said, the lowest pH we've recorded on bleak clough is 2. Lemon juice is 2.4, so that gives you some sort of idea of the conditions that we're trying to get plants to grow in. And so we treat it with lime and fertiliser. Again, that's all put on by helicopter, and we've applied over 3,000 tonnes of lime and fertiliser since we started in 2003. So the sort of scale of the works that we're doing is fairly significant. Going back to Black Hill, this vegetation comes back on this very, very quickly. This site was treated in 2006, and this is 2006. So this is within about 6 weeks of the site being treated, and you've got the vegetation coming back on it. This is a site close to this. You can see that the grass has come back. This is in a very, very short period of time, but it does mean that what we've done is created these bizarre amenity grasslands, which we don't necessarily want to do. There are photos of early projects which suggest that it was Teletubby land. So one of the things that we've done is to add plug plants of other moorland species because we want to kick-start that whole process, and that's important in terms of the sphagnum work. Some of the sphagnum work that we've done later on. So we've added 5 species: cloudberry, bilberry, crowberry, and 2 cotton grass species. And they've been grown on by micropropagation, by micropropagation services, and it means that we can take a small amount of material and bulk it up quite significantly. And those are all planted by hand. We've planted about 250,000. I know that the National Trust have done significantly more than that. And again, they're all planted by hand and flown onto site. So, Black Hill again. So this is the summit. This is the Trig Point summit of Black Hill. Thanks to Chris for showing my photo before I come up. And this was taken shortly before the work started on Black Hill. As Chris said, the bare peat in 1971 came up to the surface of the Trig Point. This is the Pennine Way. You can see the Trig Point. I'll see if I can point it out. No, The trig point is right in the middle, next to the black. It's there. It is there. This is in 2011, and you can see that the conditions are significantly different in 2011 to then. However, what you can see from this is that the surface of the peat is still eroding at a sort of micro scale. So even when you've got this good cover of vegetation, there is still erosion happening. This is a site that I went to with Ed Lawrence from United Utilities, and you can see the peat eroding around the plants. And so what we looked at and thought, what you need to do is to get the whole surface of the peat covered. And what we need to do, what's the best thing to do that? The best thing to do that is to get sphagnum growing back on it. But these conditions aren't great for doing it. The received wisdom is that what you need to do to get sphagnum to grow back is to sort out the hydrology. And so we haven't done much hydrological work. You know, Penny said that there's a lot more of it. And I think that's true, but you'll see from the following pictures that there are some difficulties to this. Obviously, you know, you've got a site like this. This isn't in the Peak District. This is in Northern Ireland. You can sort out the hydrology on that site fairly quickly. So that's some work that we did with Northern Ireland Water. Doing peat dams, you can get the water table up to the surface very, very quickly. There are other areas in the Peak District where you can do this, where the gullying hasn't reached the mineral soil, and you can start to hold back the water reasonably well as well with using plastic dams. But in lots of the Peak District, that isn't an issue that we've got. So if you look at this, you can see that it's not going to be possible to do anything on that to sort out those sort of issues in one lifetime. And what we need to do is to stop the loss of peat and try and get some consolidation and get these gullies revegetating, because then it can start to build up the vegetation. And the thing that we use for doing that is to use permeable stone dams where the water will flow through it and material is sedimented out. I keep forgetting that I'm talking at a MoorLIFE seminar. Most of this stuff is being done through the MoorLIFE project, and I need to remember to say that. So these stone gully blocks, you know, they are trapping sediment. They trap sediment very, very well. They're trapping water behind it as well. And you know that happens very, very quickly. This dam was put in sort of one autumn, and this is within 2 or 3 months. You can see how much sediment is building up behind that dam in 2 or 3 months, and that's significant. Again, as Penny said, that 25 centimetres of peat, 2.5 centimetres of peat is lost each year from the areas of bare peat. Once you've got these dams in and vegetation coming back, you know, you're starting to create the conditions where you can get sphagnum to grow. And so in 2005, we had a site visit to Bleaklow and found sphagnum coming back on dunes of peat, which, you know, with the received wisdom that you've got, there is no way that you would get sphagnum growing back on this. And we were trying to work out what it was. And, you know, Richard has talked sort of extensively about occult precipitation and the amount of moisture there is in the atmosphere on the blanket bogs of the Peak District, and that may be more important than getting the hydrology right from the bottom upwards. And so we commissioned a survey. We commissioned Penny Anderson to do a survey for us. The main findings of which were that the reason there's no sphagnum in the Peak District is because there's no sphagnum in the Peak District. So 200 years of atmospheric pollution has killed it off, and so there's no source material. Again, looking at this picture, you can see it's critically important to get this to dry out, to stop this from drying out, is to get the surface of the peat wet, stop burning. So we set up this Sphagnum Technical Advisory Group. Most of the people on this picture are in the room, so feel free to grab them. I didn't want to show who they were. But you can see that the whole surface needs covering. Sphagnum is coming back. Sphagnum is coming back in the Peak District. One of the problems we've got is how do we get the amount of material that we need to cover all the areas of bare peat that we've got with sphagnum? And so we started talking to. I started talking to Neil from Micropropagation Services to say, how are you going to do this? You know, how are we going to take this small amount of material that we've got and multiply it? And you know, we looked at various things. We talked to Yorkshire Water about using one of their disused water treatment works as a place to grow sphagnum. And one of the things that we've been doing is working with Neil to grow stuff sort of in the labs. And it grows very, very quickly in labs and much slower in the field, as Angus will be able to tell you afterwards. One of the things that we've got to do with this, the microtopography of these sites is quite significant, because you can have areas of gullying 6 feet away from sort of little depressions on the tops of hags, where the hydrology seems to be good for getting sphagnum. So sphagnum is coming back on those. And one of the issues that we've got in terms of that is where do you target? How do you target where you're going to be putting sphagnum? And so we have sort of tried to focus on doing large areas with broadcast stuff. We have done work with helicopters. We've done trials with helicopters that has issues, and that's been more difficult. And so we sort of tried to focus. We've gone more back to spreading it by hand, because you can do that sort of large-scale broadcasting, but not putting it on the areas where it's not going to work. So the areas of Bilberry and that we showed earlier on, it's going to be very difficult for that to go. So stuff is coming back on Black Hill particularly very, very well. We've again, this is from Black Hill. This picture of this sphagnum is from Black Hill. This is on Black Hill. Remember the photos of Black Hill in 2006? We did through MoorLIFE. We did an extensive sort of survey transects on Black Hill last year, and found that approximately 3% of the surface is covered with sphagnum. When you look at that compared to what the vegetation was there in 2006, that's quite significant. These are the two publications that we paid for through the cooperative project, done by first top one done by Penny Anderson, the second one by us, and both of those are available on the website. So there's far more information in there. And the other publication is this one, which has been funded by MoorLIFE, the IUCN Peatland Programme, and the Heather Trust, which is a field guide to sphagnum mosses. And I think that if you do something for Laura, she may have some of those to give away this afternoon. And that's it.
Genius.
Thank you very much.
Thank you very much indeed, Matt. Let's just leave the doing things with Laura just for the moment. Okay, can we move swiftly on now to Angus? Angus